Alright, absolutely love this question from last year's exam. It was pretty hard. Quarter of the state got it correct, okay? And I have to admit it took me a little while to kind of be happy with it and confident that I knew the answer. So Megan walks from her house to a shop that's 800 metres away. The equation for the relationship between the distance in metres that Megan is from her house is given by this hybrid function here. So if Megan reaches the shop in 10 minutes after leaving her house, the value of A is. So this is what we're trying to find out, the value of A. But in looking at this, we're going to note that there's an unknown gradient for this portion of the hybrid function as well. Okay, so it was interesting. I gave this question to my class the other day, and actually none of them got it right. And then I asked afterwards, how many of you drew the graph of it? And not one of them actually drew the graph. So, in my opinion, anyway, I'm a really visual mathematician, and I want to see what this thing looks like. Right? I like to see always what's sort of going on. So the first thing I would do is just kind of like in the corner here, just sort of start the graph up. Okay, so I'm going to try and draw it with this stylus here, but anyway, I'll do my best. So she's walking to her shop 800 metres away. So we know at the 6th minute, okay, up to and including the 6th minute, this function is the relevant function. Now note that there's no y-intercept on this. So this is just distance is 100t up to the 6th minute. So if I sub in 6 for time, the distance will be 6 times 100, which is 600. Okay, so there's the coordinate point there, going from the origin up to here. Alright, now what happens is at time 6 to another time, she stays 600 metres from her house. So you can imagine what happens. She, at 600 metres, bumps into a friend, bends down to pat a cat, whatever she's doing. Alright, so the function will have no gradient, or rather, I shouldn't say that, that's zero gradient for a time. Okay? From the 6th minute to an unknown number of minutes. Then at some point what she does is she then develops a gradient, so starts moving again, okay, and ends up at 800 metres. Alright, so I'm going to draw that on the graph. Excuse the scale's off, but it's not important. So this is going to be at the 10th minute, and we know that she is 800 metres away. Okay, so that's when she reaches the shop. Now at some point on this line here, between 6 and 10, is when she takes off again, okay, and when she develops a gradient. So she's got zero gradient here, okay, because the distance doesn't change. The distance is always 600 from the 6th minute to an unknown number of minutes between 6 and 10 minutes. Okay, so let's find out this k value, alright, because once we find out the k value, we know what this function will look like. We can sketch it and then go from there. So how are we going to work it out? Well, exactly the same as this one here. What we know is it has a 0, 0 y-intercept. That is, it goes through the origin because there's no plus or minus or anything here. So I know that this function goes through the origin, 0, 0, but I also know at time 10 that she will be 800 metres away from her house. Now that's great. So what that means now is that we can work out the function for this. Okay. Now we can do it by just looking at the change in y values, which is 800, over the change in x values, which is 10. So I know that the k value will be 80, okay, or her gradient will be 80. So the function is d equals 80t, okay. Alright, so what that means is that line will, will go like that. So this intercept point here will be will give us the t value here, okay? And that's what we're interested in, okay? So I know that this equation here is d equals 600. So we're looking for the intercept between d equals 600 and d equals 80t. So again, there's a couple of ways you can do this. If you're comfortable with the maths, you can just go 600 equals 80t, t equals 600 on 80, and go over to your calculator, 600 divided by 80, and t equals 7.5, and there it is there. Okay, so you could do it like that. You could, if you're sort of mental blank or whatever, or not so strong with the maths, although if you're up to question 8 and getting this far, I'd expect you would be, but just solve a system of equations, and we've got y equals 600 and y equals 80x. Typo. And 15 on 2, which is, if you want to approximate, 15 divided, so I put 15 point, just to put a decimal point in indicates that you want an approximation. 7.5 is our answer. So a pretty hard question there, but yeah, look, once you sort of draw the graph up, in my opinion, it becomes a whole lot more accessible.